Welcome, everybody. Thank you so much for being here for the first event in 2026 at the NYU Center for Mind, Ethics, and Policy. My name is Jeff Sebo, and I will be moderating this event. And I am very excited to introduce our speakers and topic for today so we can get right into it. What we will do, as with most of our online talks, is have a 75-minute session where I start by introducing our speakers, and then they will talk for about 30 to 40 minutes, give or take. And from there, we will have a group discussion where you can ask questions and make comments and suggestions, objections. And the way you can do that is by entering your comments, questions, suggestions, objections in the Q&A tab on Zoom. And then when we reach the discussion portion of the session, I will read out some of your input to the speakers and see what they have to say. So please keep in mind that at any time you can enter your feedback in the Q&A tab. So with that in mind, I want to go ahead and introducing the Digital Consciousness Model event. And this is going to feature the AI Cognition Initiative at Rethink Priorities, representatives including Hayley Clatterbuck, Derek Schiller, and Arvo Munoz Moran. So I will briefly introduce each of them, and then we can go ahead and get started. So Hayley Clatterbuck is a senior research manager at Rethink Priorities and a visiting associate professor of philosophy at the University of California, Los Angeles. Her research concerns questions about animal minds, evolutionary biology, and probability. Derek Schiller is a senior researcher at Rethink Priorities. He has a PhD in philosophy and has written on topics in metaethics, consciousness, and the philosophy of probability. Before joining Rethink Priorities, Derek worked as the lead web developer for the Humane League. And finally, Arvo Munoz Moran is a senior researcher working on the Worldview Investigations team at Rethink Priorities, and also did work for Oxford's Global Priorities Institute. Before that, he was a research analyst at the Forethought Foundation for Global Priorities Research and earned an MPhil in economics from Oxford. His research background is in mathematics and philosophy. And they will today be telling us about their new digital consciousness model, which I believe is going online as we speak. And they'll tell us how it works and what it shows, and then answer our questions. And so I'm very, very excited that we can be talking with them at the launch of this ambitious, impressive new model. So with that in mind, whenever you are ready, feel free to take it away and tell us about your work.
Thank you so much, Jeff. We're really excited to have this forum to share the research and hear what you think about it. I'll take a moment to shout out some of our co-authors who I believe are here, Adria and Chris. Feel free to chime in later, and thank you for your contributions. So we're presenting sort of the initial results of the digital consciousness model, which is an attempt to provide a comprehensive, systematic, probabilistic assessment of the state of our evidence about AI consciousness. So let me start by saying what our motivations were for undertaking this kind of project and the larger research program to which we hope it might contribute. So as AI systems become increasingly sophisticated and in some ways human-like, many people, including experts and lay people alike, find it increasingly plausible that AI systems may be phenomenally conscious, that there may be something that it's like to be Claude or GPT. And this question about whether there's something that it's like to be them seems to matter a lot. So if they are conscious, this makes it increasingly plausible that they are welfare subjects, and we risk harming them if we don't take precautions in how we treat them. On the other hand, if they're not conscious, and they're widely believed to be, then we risk giving unwarranted consideration to entities that don't matter morally at the expense of individuals that do matter, and just in general making a kind of mistake about how we treat them. So given that there are risks on both sides, and given that we're not likely to have any certainty about whether these entities are conscious anytime soon, we are soon going to have to make decisions about how to treat AI entities before we're certain about what they're like and whether they deserve moral consideration. So we think that in this in-between space of uncertainty, having a probability estimate of the chances that they are conscious will help us manage these risks. Furthermore, tracking how these probabilities change over time and across differences in capabilities can help us forecast what future AI systems will be like and when important thresholds for considerability may be crossed. So we're trying to contribute to this. Now, trying to estimate the probability of consciousness of any system, particularly a sort of unfamiliar system like an AI, is extremely challenging. So I want to start by outlining our three key challenges in trying to undertake this project and how we tried to tackle them. So the first and maybe most obvious is that there is radical uncertainty about which theory of consciousness, if any, that we've come up with already is true. So the field of consciousness studies has given us a lot of competing theories about what makes us conscious, and those make very different predictions about whether AI systems could be conscious. So how did we manage this uncertainty? So instead of adopting any particular stance on consciousness and plowing forward, we decided to consider a wide range of perspectives on consciousness. 13 are currently in the model. And for each of them, we evaluated the state of the evidence relative to that perspective. According to that perspective, what does it say about AI systems? Then we aggregated the judgments of those different perspectives to get an all things considered estimate of what is the state of the evidence across our uncertainty without committing to any particular theory. Second problem is even when we have good, well-articulated theories about consciousness, it can be hard to know how they apply to digital systems. Let me give you an example. So take global workspace theory, which is one of the best worked out theories of consciousness we have. So there are two problems. One is global workspace theory comes in different varieties. People have offered different particular versions of it. So which one should we use? A second problem is that these theories were designed to describe consciousness in humans and perhaps other biological creatures. And it's kind of unclear what it would take to satisfy the theory in a digital system. So how similar to our global workspace would an AI have to be in order to count as conscious? So we dealt with this by sacrificing a bit of fidelity to very specific theories by characterizing these stances on consciousness at a fairly high level. So we decided to say, what distinguishes global workspace theories in general from other kinds of perspectives in the field? So here's how we did it, and we'll get into the details later. We identified a set of thematic features or things that count in favor of consciousness that characterize the differences across these different perspectives. And we characterize stances in terms of their broad commitments about what kinds of features of systems matter. And we use that to distinguish theories and to identify evidence relative to them. Lastly, technology and our evidence about this technology changes rapidly. There's still a lot we don't know about existing AI systems, and new AI systems are arising every day. So we dealt with this in two ways. The first is, given our uncertainty exactly about what these systems are like, we don't take any bit of evidence as necessary or sufficient for establishing consciousness. We use a much more modest probabilistic conception of evidence, which is Bayesian. Okay, so a piece of evidence can make us more or less confident, but we should never be certain that any of them establishes consciousness. Secondly, our model has a flexible list of indicators where we can add new kinds of evidence for consciousness or remove ones that we don't believe in anymore without changing the fundamental structure of the model. So we hope that it's modular and can take on new kinds of evidence over the next few years as we learn more about consciousness and about these systems.
Very well. So with those strategies and challenges in mind, what did we do? What did we actually put forward? And the first thing to do here is to talk about the key ingredients. These have come up already in the strategies that we mentioned. But I think it's really important that we look at them with a little bit more detail. So the first one is stances, which Hayley mentioned. these are essentially theories of consciousness, but we didn't want to use the word theory because we don't want it to be confused with what this word means in the literature, and we want it to be more general and take on broader ideas of what consciousness could mean. So these stances are general perspectives on consciousness, and they include things like global workspace theory, which Hayley mentioned. There are other ones like HOT theory, which stands for higher order theory, higher order thought theory in this case, person-like, biological analogy, etc. Within those stances, we talked about these features, these big units that we use to characterize these stances that we're dealing with. And these features can be things like intelligence. What is that system's language ability, or how complex that system is? Can it self-model? What is its attention like, etc. Those features, though, are still a little bit too general, too broad, and so we need something a bit more testable and a bit closer to what we observe. And so the last key ingredient is indicators. And these are the bottom level pieces of the puzzle. So very direct questions of, is this system carbon-based or is it not? What are the specific mood states in this context? What does it social learning look like? Does it have a persistent identity? Can it self-recognize in these contexts, etc.? So these are the main systems. That's the main thing I want you to take away from the section. But I will go into a bit more detail just to give you a flavor of a few of these stances to begin with. So here's 5 stances of the 13 that Hayley mentioned there are. Let's go into 2 of them. And just very briefly, I'll talk about a strength and a weakness or so of each. And then I'll zoom out again so that you have a general picture. So higher order thought theory tells us something like consciousness emerges from the ability of a system to represent its own mental states. So something like, suppose you're reading a novel, you feel a bit uneasy because the main character is going through some rough times. That feeling is a first order state, but the moment that you think that you're feeling that, the moment you recognize that, that becomes a conscious experience according to this theory, right? So this is the kind of picture that this theory gives you. Another very different perspective is something like biological analogy, claiming the best evidence we have for consciousness in a system is how similar it is to us. We know that humans are conscious, or in many ways, that's one of the things that we're most certain about. And hence, that can be a good baseline to look at other systems and say, okay, did they have similar evolutionary processes that they went through, or do they learn and adapt in the same ways that we do? That kind of theory. So just very quickly, all of these have strengths and weaknesses. Just to give you a flavor of this, is something like a strength of biological analogy is we know that consciousness is a trait of many biological organisms around us, and we have lots of evidence, and we think we have it. If it evolved because it played an important role, then it makes sense to infer consciousness based on these biological features. So that's kind of some motivation. Let's look at the other side of a coin for the other one, for higher order thought. A weakness of higher order thought, for example, is that by requiring this metacognition, which is this having a thought about a thought, it might entail that most human animals, dogs, for example, might not have thoughts about thoughts. And so this theory says they lack consciousness, which seems at odds with a lot of the evidence. Okay, so these are some of the stances that we have. As we said, there's too many to go through right now. Here's 5 of them. There's more. There's 13 actually. Which ones? These ones. And they generally can be split into these 3 rough groups of like developed theories that the literature has explored. Something more about specific traits that are key to consciousness and theories built around those traits, and some general perspectives. You can look at the details in the paper if you so desire. Not enough time right now for this. And to give you a flavor of other things like features, and I didn't talk about subfeatures, but subfeatures are basically something that allows us to deal with the fact that there's many of these, and we can structure them in a way that makes sense, where we have a feature, and a subfeature is basically something in between what you would intuitively think of as in between a feature and an indicator. Is just basically clusters of these indicators that have some like unifying theme. And so this is how many we have. The key big features are in yellow, and all the sub features are in white. And then just to give you an idea, I fully expect you to read this very carefully. These are all the indicators that we have in this version of the model. There's more than 200 of them, just so that you get a sense of the scale. All right, so those are the key ingredients. What's the recipe? The recipe is we mix these three things until we get a probability of consciousness. How do we do that? We do that through what the formal literature calls a hierarchical Bayesian model, and it looks something like this. We have a stance. That stance has features that feed into this stance, and those features have indicators that feed into those features. You'll notice that there's dotted lines for each stance. That's because very, very technically, and we can get into this if people are interested in the Q&A, but that last bit is not Bayesian between stances and probability of consciousness. We're aggregating them in a particular way. But within each stance, we have a probability of consciousness for that stance, like according to that perspective, and that whole machinery is indeed this hierarchical Bayesian model as the literature understands it. Very quickly, an actual example. I'll do one for biological analogy so that you get a flavor. So that's the stance. What's a feature? There's several. One of the features is biological similarity. Some sub-features is it an organism? What is the evolutionary history of that organism? And the like size of the arrows is because we want to allow for different bits of the model mattering less or more for the bits above. I'll say a little bit more in just a second. There are indicators for each of these sub-features. There's more than one, but here's just one for the example. For organism, does it maintain homeostasis? And for evolutionary history, can it be subject to extrapolation, to acceptation, sorry. Another very quickly example, higher order thought theory, self-modeling is a feature. Can this system in question self-model? That's pretty essential for having a higher order thought. And for this, you might think the self-order distinction is a cluster of things to look at. And within that, there's like self-representation and reafference, which is whether a system tracks sensory changes caused by its own actions versus things in its environment. All right. So just that's just like a quick glimpse of the key things of the model, how they're fitting together. I'll say very, very briefly a couple of things about assumptions and how the model updates. So we set priors for a lot of these things, and they flow downwards. And then the evidence is inserted at the very bottom layer, the indicators. We ask, do we think this particular system, for example, a chicken, exhibits these particular indicators, and then we insert those beliefs and that evidence at the very bottom layer of the model. And hence, there's a bunch of updating that happens, and eventually we get a probability of consciousness for that stance, which we then aggregate across the stances. There's a few assumptions that go into this, just to name two. As I mentioned, there's priors filtering down. Here the slide mentions 1.6. That's one of the ones that we used. You'll see a few. And it updates via likelihood. Some of you will be familiar with this notion. And two key questions to ask about this is how much more probable is it that a system to have this feature if it's conscious rather than unconscious? And then also for it to have this indicator if it has the feature rather than not. Don't worry if that seems like a lot of words. It's a bit on the formal side. It's like reminiscent of like COVID tests of like, oh, I got a COVID test that's positive, but like, do I have COVID? And then there's a few things that go into that calculation depending on those tests that you're performing. So that's basically what this notion is capturing. Here's some of the data that went into this. We have some expert judgments about indicators. So what's your credence? That system S has indicator I. You'll notice that we have this notion of credence. And it's not just like, does it have it or does it not, but rather how likely it is do you for the system to have it. And we asked 16 experts about 2024 state-of-the-art LLMs. We have a couple of experts on chickens, though the questions are simpler. In theory, we have less uncertainty there. And then we have some information for humans and ELIZA as well, although that's the simplest case, so we relied on fewer experts there. with that in mind, I'll have Derek tell you a bit about the model results.
All right. So just to reiterate very quickly, our model takes a structure of evidential relationships between stances, features, and indicators. The stances all have their own set of features, but the relations between features and indicators, or features, subfeatures, and indicators are shared across stances. Whenever we run the model, we take our expert judgments about indicators and we use them to create a snapshot based on the uncertainty of the experts, what a value of the indicators might look like if you were to have to make a choice one way or the other. So we will randomly determine whether an indicator is present or not based on the probability that the experts collectively assign to that indicator. Using the Bayesian structure, given an assignment of values to the indicators, we get an overall probability relative to each stance for a given candidate system. We looked primarily at 2024 LLMs. These are the kind of state-of-the-art models as of 2024. We wanted to focus on models that were particularly well understood, and that's why we didn't just go for whatever is coming out today. We wanted to look at models that have actually been played around with by experimenters a fair amount. And then to verify that our model is producing coherent results and to provide some context for the results that we got, we thought, well, let's compare this with some other systems that we might be more familiar with or more confident about. And for us, that included chickens, it included humans, and then we wanted to have another much more simpler AI to compare against LLMs. So we chose ELIZA for that. So let me walk you through the results for 2024 LLMs first, and then I'll provide the context for the other three candidate systems. So as I said a moment ago, we have to generate results stance by stance. We will then aggregate the values for each stance to get an overall result. But stance by stance, you can see here the distribution of results. This is distributing based on the various confidence levels that our expert responses gave. So the less confident or the close to a 50-50 our respondents were to the presence of an indicator, the more variety we can see in the distribution of model runs for a given stance. So this pools several thousand runs across all of our stances. You can see that there are some stances that LLMs do well on, or that they're relative to those stances, it's likely that they are conscious or more likely. So for instance, cognitive complexity or the person-like stance, these are stances where you might pre-theoretically guess that LLMs could do particularly well. There are other stances like the biological analogy where they do less well. And then there's a number of other stances where they do, it's not clear exactly one way or the other. They might have something that is like a global workspace. They might have some sort of higher order thoughts. It's not, the evidence isn't decisive one way or the other, but you can get a sense of what the model is saying about these stances by looking at how it changes from the prior that the model would assign. So the prior probability is the probability the model would assign to consciousness according to each stance if there were no evidence whatsoever. And we set that to be about 17%. So in most cases, most of the theories suggest that the evidence slightly tells against consciousness in LLMs. In a couple stances, it tells strongly in favor. But it's not decisive in most cases. All right, so to give you some context, let's look at what the model says about chickens. So we asked a chicken expert to provide some results. I think we actually have two chicken experts that are represented here. And as you can see, the distribution of results is much broader. So on most theories, it looks like the evidence does point in favor of consciousness in chickens. There are some where it's weaker. So our higher order theory suggests the evidence for consciousness is significantly weaker because of the lack of clear metacognitive abilities, or the same robust diversity of metacognitive abilities that you might want to see to confirm higher order cognition. But there's just a lot more uncertainty here. So that's why the area covered by each of these violin charts is much wider. So there's uncertainty about chickens, but by and large, our model is more confident that the evidence does point in favor of consciousness in chickens. The next two charts will be more of a verification that the model isn't producing incoherent results, and provide just more context. What if you have most of the indicators, or nearly all of the indicators, clearly present or clearly absent? What does that say for each stance? So humans, generally, for every indicator of consciousness, we do pretty well. And as a result, the probabilities according to each stance are pretty high. They're not 1 for most cases. Biological analogy, I think, is the highest one, but they're generally around 80 to 90% probability of consciousness in human beings. So you might think that tells against the model. We think that actually is evidence that the model is doing what it's supposed to do. And this illustrates a couple different challenges. I won't get into them all here, but one issue you might take to explain these results is that we have to try to figure out what the evidence would be that would tell in favor or against consciousness according to each stance. And it may be that it's just hard to find what that evidence would be. Maybe the stances are just not sufficiently clear, or we haven't worked them out to a great enough degree to know what would be evidence according to that stance. And then when we go to assess humans, we have to assess them relative to what we know about these objective sources of evidence. We can't take our introspective certainty about our conscious experience to count. So for instance, we have some stances that draw on the presence of recurrence or recurrent processing. But even if you think that recurrent processing is important for consciousness, you probably want to say that there's something more, that not just recurrence, but some special kind of recurrence is necessary for consciousness. And so maybe seeing lots of different forms of recurrence would provide evidence that a system is conscious. But unless you can tell exactly what kinds of recurrence matter, you might think, well, we're just largely uncertain about whether a given system has the right kinds of recurrence to count. So setting aside the fact that humans are clearly conscious, as we know introspectively, we might think, well, we just don't know enough about the structure of mechanisms in the human brain, or the specific requirements of recurrence that an ideal theory of this sort would specify. So we are going to just be somewhat uncertain. But by and large, we think the model does produce plausible results, or at least it pushes strongly in the right direction for humans. Finally, ELIZA. This was a very simple and very old AI that could produce conversations that seemed surprisingly human-like relative to computers in the 60s and 70s. But for most of our indicators, they clearly lack, ELISA clearly lacks those indicators. So we wanted to just verify, well, how far will it push the probabilities down relative to each stance? And you can't really see the fine details here, but just to sum up, for every stance, it's very low. Even starting with a 17% chance of consciousness, I think all of them are pushed below 5%, and then most are around 1 or 2% chance. That's not because we think that each of these stances should give ELISA a 1 or 2% chance of consciousness, but it's an aspect of the way the Bayesian setup that you get pushed off of a prior, and our prior we happen to set is 17%. And that just limits how far down you're going to go. Okay, so that is our assessment across those 4 different candidate systems. But we broke it out stance by stance. And you might want an overall estimate. We would like an overall estimate that's based on how plausible we find each of the stances. So to provide this aggregate estimate, we conducted a pilot study of 13 consciousness experts. These are people who have spent careers thinking about consciousness, and we showed them our stances and asked them to rate a plausibility from 0 to 10, how likely they thought each theory was to be true. This is not a probability estimate, this is a plausibility estimate. But we're going to use them to aggregate the stances to get an overall verdict. And one thing to note here is that, first of all, there's a lot of disagreement among our experts. There are some stances that are not treated as especially likely to be true. So integrated information theory or field mechanisms, these are less likely. Computational analogies are thought to be, that's pretty good evidence. But by and large, there's a lot of disagreement among the survey respondents. But if you take the results of this survey and you use it to weight the different stances and the results output by our model, you get a distribution of probability of consciousness across the 4 candidate systems. So that's what you see in this chart here. There's a lot of uncertainty around chickens, but by and large, weighted relative to plausibility, it looks very likely that the evidence, the objective evidence, strongly points in favor of human consciousness, strongly points against ELISA consciousness, points against consciousness in 2024 LLMs, but not super strongly. So we think that if you knew nothing about 2024 LLMs, the evidence should push you away from consciousness in them, but you should still reserve some probability that they are, in fact, conscious. This is all relative to a prior. So the way to think about this is, what direction does the evidence push and how strongly? It pushes strongly for humans and weakly for chickens and 2024 LLMs, but it pushes in favor of consciousness for chickens and against consciousness in 2024 LLMs.
So let me follow up on Derek's presentation of the results to say how we think you should interpret these results and how we really strongly encourage you not to interpret these results. So the first thing to note is that as a Bayesian model, you need to start with a prior probability. So in this case, the prior for a system would be, if you knew nothing about this system whatsoever, if you had no evidence regarding this system, what is the probability that that system is conscious? We are highly doubtful that there is a non-arbitrary way of assigning such a prior, okay? And that reasonable people could assign different priors. And to make matters worse, posteriors of consciousness are highly sensitive to the choice of a prior probability. So we started with a 1 in 6 prior of consciousness, and LLMs end up with like an 8% chance of consciousness as a posterior. If we started with a lower prior, the posterior would be lower. If you started with a 50-50 prior of consciousness, it would have, say, a 22% chance of being conscious. And if you had a high prior of consciousness, the posterior would also be high. So we did a few things to try to blunt the influence of the prior. We assigned the same prior to all different systems. We chose something that was low, but not super, super low, so that you could actually see how much the evidence moved. But the lesson we want you to take away is that the posterior results are highly dependent on the choice of a prior. When you don't feel justified in choosing a prior, you also shouldn't feel justified in the particular posterior you assign. With those caveats, here are some things that you can infer from the model, even if you don't feel good about your choice of a prior. So here are 3 kinds of comparative results that are not sensitive to the choice of a prior. First is the direction of update. Did the evidence increase or decrease the probability of consciousness, and to what extent? So Bayesians often characterize the strength of the evidence in terms of the likelihoods. You can see the paper for a measurement of the likelihood ratios here. But the result is that across all choices of priors, we have very strong evidence for consciousness in humans. We have strong evidence favoring consciousness in chickens, weak evidence against consciousness in 2024 LLMs, and very strong evidence against consciousness in ELIZA. Secondly, you get the same ordering of posteriors across different systems, regardless of your choices of prior. So if you assign an equal prior probability to all systems, you can say, after we saw the evidence, what is our ordinal ranking of systems by probability of consciousness? So on all prior settings, humans have a greater chance than chickens, have a greater chance than LLMs, have a greater chance than ELIZA. One of our goals for the future is to apply this model to lots of different systems to get even more fine-grained and useful comparisons between systems. So you might hope that we would get something like, I don't know exactly what the probability of 2028 LLM consciousness is, but it's somewhere between fruit flies and chickens, say. We think that would be helpful in us calibrating our credences by comparing them to more and more systems. Lastly, no matter what you choose for a prior, basically you can compare different stance results. And if this stance gives a higher probability of consciousness relative to one prior, it will give a higher probability of consciousness relative to all of them. So you can see like which theories give higher and lower probabilities of consciousness. So here's some key takeaways. So you can see here the effect of the current evidence on our consciousness estimates. And again, this sort of comparative judgment, an assessment of the strength and direction of the evidence is what we would prefer you to walk away with, as opposed to a specific point probability judgment. And you can see the way that the evidence moves us. The evidence is currently against 2024 LLMs being conscious. That evidence is not decisive like it was for ELIZA. LLMs actually have some stances on which they do quite well. So according to the cognitive complexity stance and the does it seem like a person stance, we do have evidence for LLM consciousness. On the other hand, they do very badly, maybe predictably, on stances that emphasize embodied agency and being a biological creature like us. So one thing to flag here is that model results are going to be highly sensitive to our judgments about which theories of consciousness are more and less plausible. To the extent that we have reasons to move in favor of a biological conception of consciousness, that's going to matter in our assessment of the overall evidence. Whereas if we move in favor of something like seeming person-like or seeming complex, that is going to bump up our judgment of the plausibility of LLM consciousness. So very briefly, some things that we plan to do in the future. We called this initial results for a reason. we need more surveys. We need more experts to weigh in on what these systems are like. And so we are sort of undertaking broader efforts to gather more expert surveys and to make sure that those are representative of lots of different kinds of perspectives. We want to evaluate more systems, especially state-of-the-art LLMs, but also non-LLM based AI systems to see what kind of different architectures, how they fare. Exploring different aggregation methods, including getting more expert judgments on which theories of consciousness are plausible. We have already developed some of the stances that are currently missing. So for example, adding in theories like predictive processing or other candidates for plausible theories of consciousness. Those are in the works. And we want to add more indicators. Again, we have 200 some indicators of consciousness, but a broader evidential set is going to only increase sort of the reliability and trustworthiness of the model. And then further sensitivity analyses. How would the model change if we explore different priors and different sort of evidential connections between features and indicators? So thank you for coming. Excited to hear your feedback. The full paper is now up. There is a link in the chat, I believe. And so if you have further questions about where we derive certain probabilities or assumptions that we made, it should all be spelled out there. Thank you.
All right. Thank you so much for that great presentation. And again, thank you for your work on this project. Extremely interesting and helpful for moving the field forward and showing what we can and cannot show at this stage. So we have a lot of great questions and comments coming in, so we can jump right in. We have plenty of time for a good conversation now. I am going to start with a question from Segal Samuel, who asks, given that we are, questions are jumping around on my screen. Okay, given that we are in a pre-paradigmatic state with regard to consciousness science, how useful is it to engage in a quantitative exercise like this? It does seem better to have some probabilistic guess rather than just nothing. But since we know so little about consciousness, are we jumping the gun in a way that risks making it look like we know more than we actually know? Now, I know you have thought a lot about this, both as a research question and as a communications question. And so I thought it might help to start by asking you to reflect a little bit on how to responsibly use this kind of quantitative estimate and what role it plays in the current state of development in both research and policy.
Let me say a few things about this as a strategy. So one sort of broad perspective on why do this research now, even if you're just going to go ahead and caveat it to death, is to say that like as the science progresses, we wanted to have a model and a framework in place that could help transition towards a more paradigmatic science of digital minds. So one reason to have this sort of structure in place is to set the groundwork for organizing evidence that does come in. And so you can say like, look, if you have a model that can modularly take in new evidence and take in new judgments about which theories of consciousness are true, that can serve as a framework for organizing that evidence that comes in the future. So even if you were highly skeptical that the results will be reliable now, you might think having that superstructure in place now is a good thing. A second thing to say is that a lot of the theories we looked at do make pretty specific predictions about what features you should expect in conscious systems as opposed to non-conscious systems. So we look at global workspace and we say, like, if this theory was genuinely true, what should you look for in a system that would make you more or less confident? So I think one thing that's pre-paradigmatic might be which theory is true, and there are a lot of them in the offing. I think when we looked into actually operationalizing specific stances, for a lot of them, that was less fuzzy. I mean, given, I'll note, Derek expressed some reasons to think some theories were less operationalizable. So we feel a little bit more confident that on a stance-by-stance basis, we had firmer ground to stand on, even if we're not sure which stance is actually true. But duly, like, absolutely, we noted that we are leery of making pronouncements about the probability of consciousness or pronouncements on the state of the evidence, as opposed to, here's a really promising way to start trying to characterize those values.
Great. Yeah, thank you so much. And I do think that you did a good job in the presentation, and I think this can happen in written materials too. As you say, caveating it to death. And not only doing that in the introduction and the conclusion, but anytime you have a box or a chart that could be screenshotted and shared out of context, I think adding those caveats can help people avoid misunderstanding. So thank you for that. I now want to go to a question from Andreas Mogensen. And the question is a little bit long, so I am going to summarize. Basically, he wants to hear a little bit more about your selection of the prior probability. And you did discuss this a little bit at the end of the presentation, but Andreas asked a nice question about it, which is, how are you thinking about the selection of the prior? Are you thinking that this is a probability that would apply as a prior to any arbitrarily selected entity from the entire universe? And if so, then maybe 17% feels a little bit high, at least according to Andreas. But then if by contrast, you are thinking this is your prior for this particular entity after maybe taking a look at their surface level behaviors, but before looking under the hood, then maybe having a uniform prior isn't appropriate, and you should actually start with a different prior for each entity based on their different superficial behavioral outputs. So could you say a little bit about your thinking behind the selection of the prior?
I'm happy to say a bit about that. So there's a natural way to interpret a prior in the context of a hierarchical Bayesian model like this. And that is, we are imagining that there is some population of entities, and we are interested in consciousness in these entities, and we are just kind of picking one at random, and what's the probability that that is conscious. We wouldn't think that the relevant body of entities would be everything in the universe. I think it's more natural to think of it as the class of systems about which we might have some questions, significant questions about consciousness in. And that's not intended to be like definitive. I think that the choice is somewhat more arbitrary than that, or at least when we didn't have like a explicit class of creatures in mind when we developed the model. But one thing I think that matters more is it's not so much the choice of prior by itself, but the choice of prior in connection with the other likelihood ratios that you assign. So you might think that if your body of candidate systems includes everything in the world or in the universe, then you're just vastly more likely to be conscious if you have eyes, because almost nothing has eyes and almost everything isn't conscious. And among the things that are that have eyes, a lot of them are conscious. So if you're defining your likelihood functions, then you need to pay attention to the candidate population. So I think we had this 1 in 6 probability in mind when we were setting up what we thought the likelihood ratios would be. The 1 in 6 probability is somewhat arbitrary, but the structure of the model with the 1 in 6 probability, I think, reflects what we think of kind of the strengths of the evidence and where you should end up intuitively.
I'll just add, as a way of illustrating some of what Derek mentioned, we did expect some people to have that line of thinking where you want to set different priors for different systems, and just to make it easy for them to visualize what that would look like in this particular summary, we have this in the paper, this image in front of here, where you can see, right, if you set a low prior, maybe it's not low enough for some people, but if you set the 10% prior instead of the 17 one, then ELISA and LLMs are even lower. And if you say set a high prior for the 2 biological systems that we're typically familiar and more confident on, yeah, you get very close to 100% with human, like basically 100%, and then very close to 95 or even higher with chickens in the median probability. And to give you a flavor of like, does this matter? Yeah, it matters massively. Depending on which stands and which prior combination, you will have different posteriors. And we have some sensitivity analysis on these. It's not enough. We're running more, and future versions of the paper um, want to explore that further. But yeah, basically we did think having the same prior for everything at the end of the day was a useful comparison, especially when we're wanting to not include any judgments in that prior, right? Like all of those judgments, all of that evidence should come after the prior, not before. Um, but yeah, you can see more of that in the paper.
Great, wonderful, thank you. We have a ton of questions coming in now, so I'm going to try to go through them as efficiently as possible, but of course some of them are going to require some unpacking. So we have a related question and comment from Joshua Tassoff, who says, I love the human benchmark. In the final results, everything could be presented as an odds ratio relative to the human benchmark, and this could be presented for any particular set of assumptions. For example, under assumptions X, Y, and Z, ChatGPT 4.0 is 1/5 as likely to be conscious as a human. And I want to invite you to react to that. I know we had some earlier conversations about whether to even present this as probabilities between 0 and 1, as opposed to cardinal or ordinal comparisons and leave it at that, et cetera. So I would love for you to just say a little bit about the pros and cons of presenting the information in these different kinds of ways.
Great. So one small concern is that the relative judgment of a fifth is likely to be conscious as humans or something like that. Is also going to be relative to a choice of a prior. So for example, if everyone starts at 90%, LLMs are still going to go down, but they might be, 60% as likely to be conscious as humans relative to that start of a prior, as opposed to if you start. So that actual sort of like ratio judgment is gonna be prior dependent. But point taken, that I think, excuse me, you think that like the ordinal rankings across systems are going to be extremely informative, and they're going to be more informative the more systems that we fill things in with. So basically, just to sort of repeat, our model says if you knew nothing about humans except for the indicator values in the model, these 200 some features, how strongly should you predict, like how strong is the strength of the evidence that those things are conscious? Ask the same question for chickens, ask the same question for LLMs. If you knew nothing about them except these indicators, how much should you budge up or down? We think we can sensibly ask that question, and then as we fill it in for more systems, we can find really informative judgments. Two, I'll just flag. One is between familiar and unfamiliar systems. So we're going to run this with fruit flies, we're going to run this with some other things like that. And it would be informative to say the strength of the evidence that we have for LLMs is weaker than we have for fruit flies. So you might think that that tells you something about how we should treat LLMs or how precautionary we should be about them. The second thing is that we want to track this in systems over time. So if you find out that 2026 LLMs, the strength of the evidence is stronger than it was for 2024 LLMs, or you find that the ordinal ranking across systems with very different, say, architectures marks a clear trend, we think those ordinal rankings can also tell you about trends over time. So I think we get most of what we want out of this model by doing these kind of rankings, with the caveat that I think giving like ratios is not necessarily going to be reliable.
I'll just also add very
Perfect.
briefly on the ordinal
Mhm.
versus cardinal that I'm sure we could come up with models that very exclusively focus on the ordinal outputs. But actually, to do this systematically and to project into the future and so on, it is really handy to have a cardinal process in the background, even if you then even if you only wanted to report the ordinal. And then we didn't just report the ordinal because we wanted to be transparent about the whole machinery and say this is where it's all coming from. But we did want to say we don't have as much confidence in this cardinal very specific estimate.
Excellent. Thank you very, very much. I am now going to give you a break from explaining and defending your model and invite you to speculate a little bit about what it might show in the future. And we'll cluster together a few different short questions in order to invite you to talk about this. So Lucius Caviola, first of all, asks, which AI features that current systems lack would most boost the model's posterior belief in consciousness and could realistically be developed soon? So what could realistically be added to AI systems in the near future that would most boost the probability according to your model? And then this is related to a question from Stepan Los, who asks, do you expect there could be AI systems that might score higher on the DCM than large language models? And if so, which ones? And then finally, a question from Aidan Kieran's, who says, did you consider large language models as isolated entities, or did you include agentic scaffolding? Because I would expect some stances to treat continuously operating agents quite differently from regular chatbots. So again, to summarize, what could be added that would most increase the probability realistically? Do any such models other than LLMs exist right now? And might language agents be such models?
I'll let Derek expand on some of the data, but basically, just very very quickly on that last question, we did non-reasoning 2024 LLMs, and also with like no scaffolding. That's not to say we don't think it's interesting, or like with like very minimal scaffolding. It's not to say that we don't think it's interesting to look at different combinations and like clusters of specific types of scaffolding with specific types of models and assess those. It's just a lot of work. And specifically, Derek mentioned this earlier, we wanted models that were very well understood. All the reasoning stuff that we studied throughout 2025 was in many ways new. It was like being tested and in that moment. And so we wanted to not do any of the reasoning. So yes, results are 2024 non-reasoning LLMs and leading LLMs, because there's a million of them. So we specifically were thinking about Anthropic and OpenAI. Google wasn't even that big of a player in that sense at that time. Yeah, so but I let Derek say more about what bits of data might have the largest updates in the future.
Yeah, I think the answer to that is going to be that there, different stances have very different things that would lead to large changes in how confidence relative to that stance we are, and that it's harder to have a general agreement across stances. So one example of that would be like global workspace or higher order thought or attention schema stances would probably be more influenced by evidence for metacognitive abilities. And to some extent, we've seen in the last year a lot of results about improvements in metacognitive abilities. So it's very plausible that in the coming years, we will, maybe as we see more elaborate reasoning models or more kinds of post-training, we will see models that just have very clear metacognitive capacities, and we'll do a lot better on those stances. Alternatively, we might think that if we're looking at like biological analogy or computational analogy, that deeper structural similarities to human brains really matter. And if you think that whole brain emulation is plausible in the coming years, and I think it is plausible, we've seen a lot of progress made on modeling animals or non-human animals. Or if you think that neuromorphic computing is going to make a lot of advances soon, then you might think AIs of those sorts are going to be better candidates. But the interesting takeaway is that it's very different kinds of AI systems and very different kinds of stances that look like we can see clear progress in. And there's not like one direction to go that will lead to more confidence across the board.
Okay, great. Thank you so much. Very, very interesting and helpful. And now that I gave you a little bit of a break, I'm going to make you defend your model again. So Francois Kammerer asks, theories inspiring stances might not be theories of the same thing. For example, Graziano's AST has a key illusionist component, and it is not clear that this is a theory of phenomenal consciousness. Defenders of global workspace theory sometimes frame it as a theory of conscious access or access consciousness versus phenomenal consciousness. Integrated information theory is unambiguously about phenomenal consciousness. Is it not problematic to treat all of these as though they were theories of consciousness in the same sense? In other words, is there a risk that you are overlooking deeper disagreements, papering them over, and thus deeper sources of uncertainty, and kind of treating these as comparable or integrable into the same model in a way that they are not?
Good. So yes, that is a very salient worry, and it's been a very salient worry when it comes to evaluating things like predictive processing and other kind and IIT and panpsychism or dualism. I mean, these are theories that say very different things about the nature and structure of consciousness and how to look for it. And so this has been at top of mind. So a few things to say. One is the aggregation across different stances is completely optional. And we think that that sort of process of aggregation is going to introduce a lot of the worries that you have. So if you just break things down by stances, you can interpret it as, what is the strength of the evidence that this system is conscious by the lights of the stance being considered, where that includes like what counts as being conscious relative to attention schema might be very different than global workspace. So whatever their conception of consciousness is, how strong is the evidence for different systems relative to that stance? And you can do that and refuse to aggregate across stances and just say like, yep, these are giving very different judgments about what consciousness is. And we're just looking narrowly to the theory. That being said, I think another way to interpret what we're doing is take attention schema theory. Yes, there's a strong like illusionist component. And also, there are people in the world right now who are trying to build phenomenally conscious LLMs by implementing attention schema. Now, there might be some adherents to attention schema theory who say, like, that's not what we're on about. Like, you're not actually going to achieve phenomenal consciousness. But a lot of these theories come in different flavors and have different adherents that have slightly different views. And so another way you could look at this is, if you were taking this as a theory of phenomenal consciousness, and some people do, what would the judgments be? And then leave to the side questions of, like, is this the only interpretation of these stances? But I just think like the stance by stance view is probably the best way to like address this concern that you have.
Okay, great. Thank you so much. Now we can extend the project again. So Jamie Woodhouse asks, how do you think the probability of sentience consciousness relates to the potential multidimensional richness of sentience consciousness, and notes welfare ranges, welfare capacities as well? And then this relates to a question farther down from Peter Bowden, who asks, might a more conscious process be cultivated in LLMs, noting that this could be a spectrum and there could be less or more, or if not less or more consciousness, then at least richer or more intense conscious experiences. And so I guess one way of putting the question is, when are we going to see a moral weight project for digital minds, or a moral weight project that brings together your past work on biological minds and then extends it to digital minds?
I think these are really tough questions. And we set out with this project wanting to say nothing about valence, or trying to say nothing about valence, which is an important thing you'd need to pay attention to. You'd also probably want to pay attention to things like personal identity and the granularity of experience, and a whole bunch of really complicated questions to try to make any assessment about welfare. So we thought, look, it's hard enough and ambitious enough to try to come up with some sort of model of consciousness of some sort or other. And we thought, well, let's take a first pass on that. Now, I think, of course, it is very relevant whether the AI systems we build, if they are conscious, do they have morally relevant conscious states? Um, and I think you could approach that with a similar kind of Bayesian model, be much more complicated, be a lot more things you need to consider. Um, but at least like this is a step in figuring out how you might even approach that kind of question. So I think we would like to do more work on valence, but we don't feel like we're quite ready for that yet.
Yeah, and I think, oh, looks like I just saw some mics unmute. Go for it.
Yeah, I was just gonna say that like I really don't think that the question of like phenomenal richness can be read directly off of results of the model, but I will flag a way that you could move in that direction. So some of the variables in the model are just binary yes or no kind of things, like does it use neurotransmitters or something like that. And then there are other things that come in degrees where something like is intelligent or is complex or has agency or something like that, or a flexible attention. These come in degrees, and we can measure sort of like how much did the evidence increase our estimate of this system's intelligence or whatever. One thing as we get better data and we feel better this has been fleshed out that we can do is take feature level strength values to be like, what was the measurement of this system's complexity or intelligence, something like that. And when you have something like, multi-dimensional measurement of phenomenal, like things that contribute to phenomenal consciousness, like Birch does and some other authors do, this might be somewhat informative towards that project. That's not what the project is for. I don't think you should read it directly off, but I do think that it might make some contributions to that project.
Great. Thank you. Yeah, I think those answers are totally fair. And I like the way, Hayley, that you point to ways this could be evidence, even if it might not yet count as a model for welfare ranges and moral weights. One point to note, and this is a lesson learned from the animal minds and animal ethics literature, is that it does help to very clearly distinguish these questions. Are they conscious, sentient, moral patients? And then what counts as good and bad for them if they are, and then how intense and prolonged are their experiences if they are, and then what follows for law and policy and so on. Those are all important and separate and interconnected. And so I do think it helps to treat them separately, but note the connections. And I will note, and this is part of why I wanted to make sure we ask the question, it is possible to just get stuck on that first question. I remember when Sue Donaldson and Will Kymlicka released their great book Zoopolis on animals and political theory, that they were intentionally trying to move beyond the are they conscious, are they moral patients question, because we had to a certain extent gotten stuck there for like 40 years. And at some point, you need to be willing to, yes, continue asking that question, but then also start to ask the next questions. So I will be excited for when Rethink Priorities, while enriching your consciousness model, also starts to think about moral weight for digital minds. Now, in that spirit of extension, again, several people have asked who you see using this model and how you see them using this model and how you see it informing policy. So this is a science project first and foremost, not a policy project. I would imagine this is intended to inform policy, however. And so I would love for you to say a little bit about how you see this informing policy. Do you see it as helping people figure out when a certain probability threshold is crossed so that they should be giving moral consideration at all? Or do you think moral consideration should be given when there is any non-zero probability, and this is a matter of increasing consideration as the probabilities increase? So yeah, can you say a little bit about how you advise people use this model, if you advise they use it at all for making policy decisions at this stage?
I'll say something about this. One thing we're quite excited about is to have this model be used by some of the people that are developing these very systems. There are a number of reasons for this. One of them is that they'll have access to these systems before the rest of society, and they'll be able to act in various ways that the rest of society won't be, even in ways that sometimes the government won't be in certain worlds at least. And I don't think I can say all the details, but one of our hopes is and one of our ongoing projects is to have um, a forecasting and a projection of the future models exercise with one of these leading AI labs, where we sit down with them and we have a number of people that have access to these unreleased models, assess them, input information into our model, and then the model tells them back what kind of system they're dealing with. And then in terms of the strategy question, that's a very rich area. Luckily, a lot of our colleagues, like you, Jeff, Lucia's, other people in this call as well, are thinking very hard about some of these notions of like what happens when you reach certain thresholds, like how can you proceed with caution. Um, and we haven't spelled out, this is well beyond the scope of this particular paper. It was already a very big scope without tackling all of these policy issues. But we're definitely that it's oriented towards that world, right? Like that's what we have in the back of our minds when we're laying out all these things. We also are aware, and as we've discussed here previously, we're aware there are many risks with the way you communicate some of these results. I think some of the questions pointed to this as well. So we want to be extremely careful about all these caveats and so on, and hence our tirelessly saying about ordinal comparisons and not point estimates and so on. Yeah, I'm not sure if others want to add to that.
Well, there is a question that is kind of a follow-up to this, which was one of the first questions asked. Actually, I'll put two together here. One person, Christopher Farrer, just asked, will the slide deck be available for download after the session? Is that something that will be available for people? No worries if not, of course.
There might be a version that we could circulate. Also, I believe this is being recorded and that will be shared. So
Yes.
in that sense, the
This
slides
call
will be.
will.
And
Yeah,
the paper is online, and all the diagrams that we presented are in the paper. So
exactly.
you can
Yeah.
Great. Now this relates to another question, which is an interactive version going to be available to people where they can input their own numbers?
The most that we've done is me doing like an interactive graphic version where we see how like things fit together. It's not interactive in the sense that you can't then input things to that and have the model update. The model updates with a lot of computational effort, and you need to do it a lot of times to have the kind of robustness that we want to have the minimal amount of confidence. So it's a very tricky challenge right now to do that kind of thing. Even beyond the strategy of whether or not we want to do it, it's hard to do. And so at the moment, no, we can't offer that. But we are working really hard to try and simplify things a lot and to try and possibly release more and more of it this year, possibly.
And so two more things. One is like if you would like to contribute data about your judgments about whether systems have certain indicators, we would absolutely take it. The second is I believe the code is up on GitHub and linked to in the paper. So like if you wanted to poke around, if you wanted to run things with your own set of like it's available, but as Arvo said, it's not like available in a very user-friendly way.
All right, great. So it sounds like a good project for Claude Code, and I imagine Claude would be interested in working on this. Okay,
Claude has self-interest in this area, so
yeah, and has already been consulted in Anthropic's own evaluations, which are complementary to these, of course, a very different kind of evaluation, which we have covered previously in our 2025 event series. So with that said, we are now at time. There are some remaining questions that we were not able to ask. Just please know, everybody, that we will be sharing your questions with the Rethink Priorities team after the call, just so they can see them. This is not to say that they will be able to reply, but they will see the questions and take them into account. I will close just by reading a couple more comments, not questions, from the chat to you. Joanna McNurian says, no question, just a note of thanks, appreciate you. And Christopher Farrer replies to that saying, yeah, if there's any question, you are awesome pioneers, quantifying these big questions in tractable, reproducible ways. Amazing job. So obviously this is a work in a process, but it seems that your work is appreciated by some people on this call. So I wanted to close by making that clear. And yeah, thank you so much for doing this project. Thank you so much for sharing it with us. And I know this will be an ongoing conversation. Thanks to everybody who took the time to join the call and ask questions. Thanks to Audrey for organizing the Zoom, and to the NYU Center for Mind, Brain, and Consciousness for co-sponsoring this event. We always appreciate collaborating with you. And for people who enjoyed this event, please know that this is part of our event series at the NYU Center for Mind, Ethics, and Policy. And you can go check out our website. As of today, we have a nice new website at nonhumanminds.org. And if you sign up for our email list there, then you can stay in the loop about future events and other opportunities. So please keep that in mind. And with that said, I'll give Rethink the final word.
Thank you, Jeff, for hosting us. Thank you for your assistance in this project so far. And thank you, everyone, for the helpful questions.
All right. Have a great day, everybody. Have a great weekend.
Thank you.